SS3 students, we continue our revision and preparing you for your forthcoming WASE and NECO. Today, I want to go further in handling another problem, another past problem in physics. Past problem in physics, we're handling 2003, November. 2003, November, part 2. Part 2, which has 5 questions to answer 3. Know that? Question number 11 says, list properties of mercury which make it a stable thermometric liquid. List 2 properties of mercury that make it stable as thermometric liquid. You know, you have mercury, alcohol, and water. And what do you mean by thermometric liquid? A liquid inside the thermometer is called thermometric liquid. So why the choice of mercury? Why the choice of mercury over others? Number 1, reasons are: number 1, mercury does not weight glass. I hope you know what I mean by being weighting glass. If you pour mercury on a glass, you pour it out, all the mercury will come out without any of them staying in the glass. If you pour mercury on your body, don't need towel. So all will go away. The way you pour water on your body, so water will go, others will remain until you invite towel to come and move it. Number 2, mercury is opaque and can be easily seen in the glass. So you know by opaque, mercury does not allow light to pass through it. It's an opaque that absorbs light, so you can see it, can read it, unlike water. Number 3, mercury is a good conductor of heat. When a good conductor, once heat is applied, it is expanded. Number 4, mercury does not vaporize easily. Doesn't vaporize, unlike water and alcohol. Put water here now, maybe by tomorrow you won't see it again. If you pour mercury here, maybe in next 3 months it remains there. Number 5, mercury has high boiling point. High boiling point. So I'm giving you 5 properties. You have to give them only 2. Next question, number B question says, explain using kinetic theory of gases why volume of a fixed mass of gas at constant pressure increases with increase in temperature. That's another gas law. Why the mass and the volume of a fixed mass of gas at constant pressure vary with increased temperature. You know, this is Charles' law. Charles' law. So when we talk about volume and temperature, talk about Charles' law. What is Charles' law? Charles' law states that the volume of a fixed mass of gas at constant pressure varies with its absolute temperature. So this is what we have to explain using kinetic theory of gases. Before I explain it, what is the kinetic theory of gases? What does that theory say? We have 3 things there. The theory says that gas consists of tiny particles called molecules. Any gas has molecules. Now these molecules are in constant random motion. They are moving, they are not static. They move from one point to another. And there is intermolecular forces holding the molecules. The molecules are not very much free to move. There are some forces holding them, although the force is weak. So having defined Charles' law and explain what is kinetic theory of gases, let me answer the question. In the exam, don't go where I started because they are not needed here. But I want you to I want to survey the environment where I can answer the question. Then let's answer the question now. You start by saying gas is composed of molecules which are in constant random motion. You say this, you score half mark. Because you have to tell them that gas contains molecules. Then, as the temperature of gas increases, the average kinetic energy of the molecules increases. Yes, if you are cooking, you are boiling water, and you increase the intensity of the light. You see water moving very fast. Maybe you want to make akamu, and you're not ready. You can lower the intensity of light, see the molecule moving sluggishly. But once you need it now, you increase the intensity of light, see the molecule moving very fast. So as the temperature of the gas increases, the average kinetic energy of the molecule increases, and the molecules bombard the walls of the containing vessel. The molecule bombard the walls of the containing vessel at a faster rate. If you now heat the wall at a faster rate, to keep the pressure the same, remember the same pressure must be the same. The molecule will have to travel longer distance between collisions. That is, have to increase. You know, initially, the size of the container is like this. It's like this. And you increase the strength of the light. The molecule will now move very fast and heat this container faster. To keep, maybe it bombards this 10 times in a second. And when you increase it, the strength of light, you may bombard it 20 times per second. To make it bombard it the same 10 times, you have to increase the volume of the container. And the molecule has to travel far distance before collision. That is to keep the pressure constant. And this implies increase in volume. Increase in volume. Remember what I said? When you heat a molecule, it will move faster than before. And moving faster than before means that you're going to heat the wall at regular interval, which is increasing pressure. To make it to heat it at the same pressure, you have to increase the volume. You have to increase the volume. That's what you need to write there. The next question says, question number 11 says, with the aid of a sketch graph, explain anomalous expansion of water for the temperature range 0 degrees C to 15 degrees C. Anomalous expansion. Anomalous means what? Irregular expansion. Let me survey the ground for you before I answer the question. All liquids except water, when heated, the volume increases. The volume increases. Or temperature or density decreases. No, volume is inverse proportional to density. But water, when heated, first of all, decrease its volume to a particular temperature before it now increase. So this is what we call irregular behavior. It doesn't behave as other liquids. So we want to use diagram to show this anomalous irregular behavior of water. So what we have to draw, very important, is like this. From 0, we say from 0 to 5. This point, so you see, this is volume and this is temperature. So you see now that volume, the water decreases in volume until you get to 4 degrees C and then now increase like other liquid. This is called anomalous expansion. If you ask a question like this, at what temperature does water has a minimum volume? Answer is 4 degrees C. If you want to do this with density, it is inverse. It is like this. With density, this is density, this is temperature, it will be like this. Here is 0. Here may be 5. Here is 4 degrees C, 5 degrees C. In the same way, water has maximum density at 4 degrees C. This is what we call anomalous behavior. Know that volume is inversely proportional to density. Where volume decreases, density increases. That's what it means. So that's it. In case they ask this one, this 2003, they ask this one. So note the diagram. The next question says that was asked is this, but I went further to explain that with respect to density. Then, so going to say define latent heat of vaporization. Latent heat of vaporization. I have specific latent heat of fusion and specific latent heat of vaporization. They are saying the same thing. Why I don't go straight to the question is to give you other way to ask the question. We have specific latent heat of fusion. This is the quantity of heat required to change a unit mass of a solid to liquid without changing temperature, or change a unit mass of a substance from solid state to liquid state without changing temperature. When we talk about latent is hidden heat. It only changes the phase, doesn't change the temperature. And when I change the phase, what you normally notice that when it enters the body, it changes the temperature. But here, temperature is constant, what we call latent heat. But in terms of vaporization, it's just the definition in the amount of heat required to change a unit mass of a substance from liquid to gaseous state without changing temperature. So, solid to liquid, fusion. Liquid to gas is what? Vaporization. Then the question comes here. This is another heat now. An electric heater, I'll solve it. An electric heater. An electric heater, a mass in water of mass M. Mass of water was M. Raise the temperature of water from from 40 degrees C to 100 degrees C. Time to do that in 5 minutes. After another 11.25 minutes, 1/4 of the water had been converted to steam. After 11.25 minutes, 1/4 of water, that was 1/4 of this mass, had been converted to steam. Calculate specific latent heat of vaporization. Yeah. Look at the question under heat. Very, very interesting. Then how do you handle it? First of all, you have to quote the formula which carries 1 mark. Formula you are going to use. That is electrical heating. We have mechanical heating. When you want to boil water, maybe to take a bath, we have 2 methods of boiling it. Either you put inside the pot and heat it either through gas or kerosene stove, or you can put a mass heater inside it what we call coil inside it to heat it when there's NEPA. So electrical heater, you have IVT, and this IVT is equal to MC delta T. MCT, and say MCT. So the two are equal: electrical heater, mechanical heater. Then IV, no IV, multiplied by 5 times 60. Why 5 times 60? This is minutes, convert to seconds, because you are working at IV. This is equal to M is unknown, but they will give you this. This is specific heat capacity of water. It's always 4200 kilogram joule kilogram Kelvin. So it's a constant that they give it to you. So I put it here 4200 multiplied by the temperature range. Delta theta means change in temperature. It means T2 minus T1, or delta 1, delta 2 minus delta 1. So that is, and it's given here from where? From this to this. 100 minus 40. Now, if you multiply this out, we have 300 IV. I means current, V means voltage. If you multiply this out, it will give you M4200 times 60. Then IV here is M multiplied by 4200 times 60 all over 300 to give us 840 M. Now, that is IV. Then we are told that after the same heater, after this 1/4 has been converted, we move again, IV again, multiplied by 11.25 times 60. Remember why 60 minutes, convert to second, to give you 1/4 ml. Remember that S is equal to ml. ml, that is formula for latent heat, ml. From here, you move where L is specific latent heat of vaporization, that is L. And that's what they are asked to find. We are coming to that. So from here, you will see that when you multiply out here, IV is this. I'll carry this now and put it here. So I'll now say 840 multiplied by 11.25 times 60 equals if you like, I say 1/4 is 0.25 ml. That's 1/4. 0.25 ml. Now we have to find L. Therefore, L is 4840 M multiplied by 11.25 times 60 all over 0.25 M. You get the answer. If you evaluate this, swap it out, you know the M and M will go here. So So multiply the upper divided by lower. Calculated. I say evaluate this yourself. Use your calculator. You arrive at L to be 2.27 exponent 6 joule per kilogram. Joule per kilogram. Then that's the question number 11. Let's quickly look at question number 14. Says state in words Newton's law of universal gravitation. Newton's law of universal gravitation. This law of universal gravitation states that, or Newton's law of universal gravitation states that the force of attraction between two particles or bodies is directly proportional to the product of their masses and inversely proportional to the square of their separation or distance apart. What are we trying to say? That the force of attraction between two bodies, what the law says is M1, M2, and 1 over d squared, that's all. Directly proportional to the product of their masses and inversely to their square of distance apart. From here, Fg is equal to K M1 M2 all over d squared. But this K is equal to K, is equal to G. Fg is equal to capital G M1 M2 all over d squared. This capital G is called gravitational constant. So that is what is there. Number 2 question says explain acceleration of a free fall due to gravity. Explain acceleration of a free fall due to gravity. What does that mean? When you throw anything on a surface, that thing will fall freely down undisturbed. And it will be acted by a constant force with a constant acceleration. You know, force is equal to MA, linear force, for under gravity, mg. So this is being controlled by this. Sometimes you may ask a question, if you release a stone and a feather or cotton wool from the same height on the air surface, will they hit the ground at the same time? If the effect of wind is controlled. If the wind is not controlled, stone will really grab before the feather or cotton wool. But if it happens in a vacuum, that is where there is no air resistance, so they will reach the ground at the same time, but they are being moved by the same gravitational acceleration. That is what I have to explain. G or acceleration of free fall due to gravity is defined as the force exerted by Earth on the unit mass falling freely under the Earth's surface or falling freely under gravity. The force exerted by Earth on a mass falling freely under the Earth's gravity. That is the definition of that. Another question says, explain the term wave-particle paradox of electromagnetic radiation. Wave-particle paradox. Sometimes they may have to explain, to give examples of wave as a particle, matter as a particle, and matter as a wave. Wave-particle paradox. It means that matter or light or photon exists as a wave or as a particle, but not as both at the same time. It exists either as a wave or as a particle, but not as both at the same time. Please, if you use "and" in that definition, it's called zero there. Because if you are given a choice to choose, you have to choose either to drink malt or to drink beer, or this, not both. So this definition has to do with "or," not "and." Okay, the time cannot permit us to move further, but I will revise more question number 15, 14, and 13 of this year. Why are you to revise past questions? As I said it before, is for you to know that your counterpart has been asked this question. So if you are praying to God, not for the question to be repeated, that prayer is not a good prayer because someone has answered this before. And they wait for you to repeat question. This is 2003. Can imagine how many years that have gone before this year. So prepare yourself. By now, you should be revising past questions. That's what you should be doing now. And in open revision, as you are revising, you use textbook to mark yourself. Or you can approach the teacher to mark it for you. If you are in WhatsApp, use my number 08032 444 127 to ask any difficult problems. Apart from what we are teaching, I will also discuss it with you. Our aim is to make all of you to pass. That's the aim of the management. You should not let us down. You should not let us down. Thanks.